All right, so this is the gas laws unit and it's going to have a lot of math in it. It's all just algebra, so don't stress too much and you get all the equations on your equation sheet. But I will be going through a lot of practice problems with you. So we're going to start talking about like gases, what they are, what they do. So their characteristics or properties of a gas, these are probably things you already know, is that they conform to their container, right? They take up the whole space. They're mostly empty space. It's not like it's filled with a bunch of particles. It's mostly empty space. So they have a very low density and they're the most energetic of the three phases of matter that we generally think of, right? Gases are moving faster and that's why they take up all of that space. They're not really affected by gravity. So one specific thing we measure based on gases that we don't really measure for other things is pressure. So we're going to talk about pressure a lot in this unit. Okay, so what is pressure? Usually you think of pressure like if you're putting pressure on something, and that does apply here as well, just like in physics. Pressure would be the force, right? It's force per area. Like that's what it is in physics when we calculate it. Pressure is force per area. So what is happening with a gas since it's mostly empty space? Well, it's the force of those gas particles actually hitting the container walls. Okay, so the particles are bouncing around, right? Moving all over the place. Every time they hit the wall, they put pressure on it. They put a force on it, and we measure that as pressure. So the SI unit of force is a Newton, and that's what you would use if you're taking physics. We use for pressure Pascal. So that's like newtons per meter squared if you were to do a conversion, which we are not going to, but it's the force per area, right? Force is Newton per area is meters squared. So that's where pressure comes from. So we tend to use Pascal. We are actually going to use a bunch of different units, which is why I have them all here in this table for you. You will see any or all of these in questions regarding gases. So the one I have starred here is the one we use most of the time, which is atmospheres. This is the one you will see almost always in questions, but we do use the other ones to measure as well. This is also probably the one you're most familiar with. So the abbreviation for atmospheres is of course ATM. The definition or the description of an atmosphere is the pressure at sea level, because at sea level, we call that one atmosphere. Okay, and then everything else is according to that one atmosphere. So I have the equations or equalities over here, so you can do any conversions with these. And I have the first one going to pascals because that's the SI unit. There are 101,325 pascals in an atmosphere. So pascals are actually very, very small units of measurement. So most of the time in this class, we're using pascals, we're going to be using kilopascals. So I have the atmosphere conversion here. After that, I have everything, converting between kind of either what makes sense, or you can use multiple conversions if you got to go multiple ways, whatever works for you. So got millimeters of mercury. That was when we actually use a barometer and we measure how the mercury moves with pressure. There are 760 millimeters of mercury. That's our symbol in one atmosphere. And torr millimeters of mercury are essentially the same thing. So we're just going to call it the same as mercury. This was a different scientist who measured something else, but they have the same conversion. 1 millimeter mercury is the same thing as 1 torr. Okay. You will also see a bar. A bar is related to pascals. So sometimes we use that as our SI units, but yeah, it's just 10,000 pascals. It's just a more appropriate unit for us to use because, right, this is a huge number. So sometimes we use bar. There's also pascals then and kilopascals. So one atmosphere we said was 101,325 pascals. And then 1 kilopascal is, of course, 1,000 pascals. So if you want the atmosphere to Pascal conversion, it would be 101.325. This is a conversion we would be more likely to use. Okay, so those are all of the units we're going to be using. How do we actually measure pressure? Well, I already mentioned this one. We use a barometer a lot of the time, and that measures the atmospheric pressure. So a barometer looks like this thing over here. It's like a little dish of mercury, and then this tube is filled with mercury, and then this is a vacuum. There's no air or gas in there. So as the pressure in the atmosphere increases, it pushes down on the mercury, which will push it up the tube. So the higher the mercury moves up the tube, the more pressure the atmosphere would be putting on it. So that's how we kind of measure it. So we say at exactly sea level, like Baltimore, Maryland is at exactly sea level, 760 millimeters of mercury. That's how high the mercury level goes. Whereas if you take it up into the mountains where we know there is less atmospheric pressure, so like it only measures 714 millimeters of mercury. So that's where the millimeters of mercury comes in. Again, this is then what a barometer is going to look like. So we will be using what's called standard atmospheric pressure. So if I say standard anything, that means I'm at 1 atmosphere. Okay, standard pressure is 1 atmosphere. So if I wanted to calculate pressure according to physics, it would have to do with the height, the density, and the gravitational constant. But we are, of course, not in physics, so we're not actually going to calculate based on that. But we will take into account the other measurements and conversions that we're talking about. So atmospheric pressure decreases with higher altitude. You hopefully know that from other classes, but as you go higher, there's actually less gas particles. So there's less pressure pushing on you, which is why you can get all kinds of like altitude sickness and things like that. There's not as much oxygen and there's not as much particles in general, or as many particles in general. So another way we can measure a gas, especially when we are in the lab, when we're doing something in a closed container, is called a manometer. Okay, so this was a barometer. This is like open air. And this is a manometer. This measures pressures other than the atmosphere. So if I have a gas in a container, I again use mercury because it's a very dense liquid. Excuse me. If you are less than 1 atmosphere of pressure, use a closed container and you can see how that mercury moves. And if it is higher than 1 atmosphere, use an open container. And again, you can see how that mercury moves. We measure the difference between the gas height and the mercury height, this difference right here. And so that pressure of the gas is essentially how much the mercury moved. Now, we won't be using manometers in class, but that is another way to measure the pressure of a gas, not one of the atmosphere though.